Okay, when adding positive and subtracting positive integers, it's good to understand for addition, and we're just talking about addition, the commutative and associative laws. It just means that you can add these up in any order that you want, and you can associate them in whatever order that you want, and you'll still get the same answer. It does not work for subtraction. We're only talking about addition. So we're going to look at partitioning, these mental strategies, so you don't need to write these down. You can work them out in your head. Compensating and doubling and halving to calculate the sum. Sum is the word that means add. Or difference, which is the word that means subtract, of positive integers mentally. So partitioning is when you take out think about partitioning as place values. So if I'm looking at 171 plus 23, let's take all the hundreds and add them together. Well, there's only one here. Then let's look at the tens. That's 70 and 20. It's not 7 and 2, it's 70 and 20 because they're in the tens place. And then these are in the units place, 1 and 2. So then if we sort of look at those brackets and we have 100 plus 90 plus 4, it's a whole lot easier to come to that in our head. Compensating is when you do a little bit of a cheat by you add or subtract a little extra number, which you'll take care of in the end. That will make it a lot easier to add or subtract. So I've got 46 plus 9. 9's kind of a weird number. Why don't I just make that 10? But of course 10 is one more than 9. So if we're going to add 10, then we've got to take off that extra one that we added. So if I just look at it this way, 46 plus 10 equals 56. I can do that in my head. And then I take off the one that I had added, and that gives me 55. So that's an example of compensating. Sort of aiming for the next 10, making of 10, even 5s. Doubling or halving is when you look at two numbers and you think, all right, these two numbers are pretty close to being the same. What if I looked at one of these numbers, say 78, as 75 plus 3? That means I've got 75 times 2. And 75 plus 75 is pretty easy at 150. And then I add back on the 3 that I took off to get my total of 153. Similarly here, if I look at 124 minus 61, well, 61 isn't very useful, but 62 is actually half of this puppy. So I'm going to account for the extra one that because we're subtracting, if I subtract an extra number, so I'm actually subtracting from 61 to 62. I'm subtracting one more than I should, so I got to add it back in. So now I can just take half of 124, and that's my 62, and add back on the 1. That gives me 63. So let's look at it for reals in real life here. Let me just move that a bit. So use the suggested strategy. So partitioning, I'm thinking place values. So I've got 100 plus 100. I'm going to put them in brackets. I'm going to add those together. Plus, and I'm only putting them in brackets because this is what partitioning is. We want to look at those place values together. Of course, we could add them in any order. So the tens is not 3, but 30 plus 50 tens. I want to think of them together. And then 2 units plus 6 units. And I want to think of them together. I kind of overwrote my plus sign there. I'll make that a little prettier. So 100 plus 100 is 200 plus 80 plus 6, 7, 8, which is pretty easy to put together as 288. So you might look at that and think, oh, I can do it. I can add 6 and 2 and 5 and 3 and 1 and 1. Well, you're doing it. You're doing partitioning. Compensating here, 25 is I'm going to leave that alone, but 19, I'm going to make that 25 plus 20, which you can probably see is going to be 45. 20 plus 5. I'm using a bit of partitioning there as well. But what did I do? If I was going to add 20 and I added, if I was meant to add 19 and I added 20, then I better take off an extra one that I added, minus 1. So we're going to end up with 25 plus 19 equals 44. And if we want to check it, let's do it. 25 plus 19. You could have a calculator. 9, 10, 11, 12, 13, 14. Oh my gosh, it works. So compensating down here, similar. We have 56 minus 18. And we're told we want to use compensating. So that's going to be adding or subtracting numbers so we get around a 10, a multiple of 10 or maybe a 5. So I'm thinking 56 minus 18. The closest thing we can get to 18 is 20. I'm not done yet, but 56 minus 20, kind of using a bit of partitioning. 50 minus 20 is 30, so that's going to be 36, but I'm not done. So I actually ended up subtracting more than I should have, because I meant to subtract 18, but I took off an extra 2. So I'll just add those 2 puppies back on. And so 36 plus 2 is 38. So again, I meant to subtract 18, which 56 minus 18, I promise will give you 38. But I subtracted 20, which is 2 more than I should have, so I'm adding those 2 back in. And then we get doubling and halving. You can see 36 and 35 in the other order. It doesn't matter, associative. Looks like both of them have a 35 in them. So 35 plus 36, I'm going to split into 35 plus 1. So I can also express that as 35 times 2, because there's 2 35s. So all the multiplication is just addition, repeated addition, plus 1. So we talked about the order of operations. BIDMAS, BOMDAS, you could say BODMAS. Remember, it means brackets, indices or orders, and then these guys are done, multiplication or division, from left to right. In this case, it's only multiplication. And then after that, we do addition and subtraction in the order they come from left to right. So that's often a mistake. You can see here that BOMDAS actually proves the point, because it doesn't matter if it's multiplication or division that comes first, we do them from left to right. So you don't need brackets around 35 times 2, but if it makes you feel better, we would do that first, plus 1. So clearly that answer is 71. Now we go to our online textbook or our hard copy textbook and go to exercises. Remember, that word means exercises, and we complete these in our exercise books.